I will present the answer for question 1 and how to get the answer. For question 1A, what is the difference between the null hypothesis and an alternative hypothesis? A null hypothesis is the statement being tested, while an alternative statement is we are trying to find evidence for a null hypothesis tested either to reject or fail to reject, while an alternative hypothesis is the statement accepted if the null hypothesis is rejected. Next question 1B, what is different between one-tailed test and two-tailed test? One-tailed test focus on specific direction, while two-tailed test examine if there is a difference in either direction. One-tailed test will only have critical regions and two-tailed test have two critical regions. Next question 1C, what is meant by a p-value? A p-value is a statistical measure that helps to determine the significance of results in a hypothesis test. Next question 1D. Have been take out all the calculation that stands in the statement. The population means mu is 6.6. The sample means x bar is 0.56. The significance level is 0.05. The sample standard deviation is 1.18 and the sample size is 7. To find sample mean and sample standard deviation, we use the calculator as I show in the video below. Here we go. Step 1. State the null hypothesis and alternate hypothesis. A null hypothesis HO mu equals 6.6 and an alternate hypothesis mu is not equal to 6.6 because the keyword in the statement changed. So obviously we use two-tailed test. Step 2, select the level of significance. There is 0.05. And step 3, select the test statistic. We use t-distribution since we don't know the population standard deviation. Step 4, formulate the decision rule. So first, we must know the critical value. Because of we use two-tailed test, we have to divide the significance level with 2. So the both side is 0.025 in the rejection area. Look at the table given. We know the level of significance is 0.05 and degree of freedom is 6 because we minus sample size with 1. So the critical value is 2.447. So we reject hash null if computed t more than 2.447 and we reject hash null if computed t less than negative 2.447. Step 5. To find t-test, we use formula x bar minus mu might divide sample standard deviation divides square root sample size. So 7.56 minus 6.6 divide 1.18 divide square root 7. So we got 2.13. So we can make the conclusion is 2.13 falls outside the rejection region. So we cannot reject the hash null. So we can conclude that the average weight adverse is not changed from 6.6.
Next, question 2a. The first step is state the null hypothesis and the alternate hypothesis. The second step is select the level of significance. The third step is select the test statistic. The next step is formulate the decision rule. And the last step is take a sample, arrive at a decision, do not reject hash null or reject hash null and accept hash 1. Then for question 2b, first of all, we have to state the x bar which is 94, mu 90, sigma 22 and n 100. For the first step, hash null, mu is less than and equal to 90. Hash 1, mu is greater than 94. The next step, we have to select the level of significance. So the level of significance that we get is 0.10 as stated in the problem. Step 3, we use Z distribution since sigma is known. For the step 4, reject hash null if calculated Z greater than 1.28. How to get 1.28 is, first of all, we have to deduct 0.5 with the significant level which is 0.10 and we get 0.4. Next, look at the Z table and find the number that close to 0.4 and we get 0.3997 and look at the row and the column of the number and that's how we got 1.28. And for the last step, we have to compute the Z statistic, which is we have to use the formula x bar minus mu divided with sigma per n square root. So we replace it with the formula with the question and we get 1.82. And when we look back at the graph, 1.82 is greater than 1.28. So we can conclude that 1.82 falls inside the rejection area and we have to reject hash null and that means the mean inserting time has been increased. Question 2c, first of all, we have to find the x bar for food 142.5, x bar for restaurant 130.3, significant level for food 12.243, for restaurant 15.787 and for food is 6 and for restaurant is 7. And because of this is the two sample hypothesis test, hash null is mu food less than and equal to mu restaurant. For hash 1, mu food greater than mu restaurant. For the step 2, significant level is 0.10 as stated in the problem. And for the next step is we have to use t distribution because the standard deviation is unknown. Step 4, we have to reject hash null if calculated t greater than 1.363. To get 1.363 is we have to look at the t table. We have to find the n. How to get n for two sample is we have to total n for food and restaurant and minus 2 and we got 11. So when we look at the t table at the significant level for one tail test 0.10 and 11 and that's how we got 1.363. Next, for the fifth step, we have to find the value of the test statistic. We have to pull the sample standard deviation first using the formula n food deduct 1 times standard deviation square for food plus nr deduct 1 times standard deviation square for restaurant and divide the n for food plus n for restaurant and minus 2 and we got 204.076. After that, use the pull standard deviation in the formula which is s bar for food minus s bar for restaurant divide square root all sample standard deviation and times 1 per nf plus 1 per nr and we get 1.535. And then when we look back at the graph, we find that 1.535 is greater than 1.363. With that, we can conclude that 1.535 falls inside the rejection area and we have to reject hash null. So the mean salary are greater for the fast food workers than restaurant workers. So the p-value for this question is between 0.10 up to 0.05.
I will explain question 3a. An investigation of the effectiveness of a training program to improve customers' relationship included a pre-training and post-training customer survey. So for 0.05 significant level, what is the decision regarding the hypothesis that the training was effective in improving customer relationship? Firstly, we need to detect what method we will use to answer the question. So there are two samples, both data referring to the customers. So as a result, we will use dependent t-test distribution. For step 1, keywords from the questions is improving. So our H1 is mu more than 0. And our H null is mu less than and equal to 0. Every question, if we use dependent t-test, the pattern will always be the same. Means that the bag will always be 0. For step 2 and step 3 is the same as other distribution, also from the question given. Then for step 4, we need to find the critical value of t. Reject hash null if calculated t more than what value. Dependent t-test is different from pool t-test in finding the degree of freedom. Independent, we will calculate it using the formula total sample minus with 1. So from the question given, there are 7 customers minus with 1 and get 6 the degree of freedom. Now look at the table t distribution, 1 tail test and our alpha is 0.05. So we get 1.943 as our critical value. Step 5, the formula to find the t is d bar divided with standard deviation per total sample square root. How to find the d bar? First, we need to find the difference for both group, post-training survey minus with pre-training survey. Isn't we always minus left from right? No, we have to refer to the question 2. Which one is mu more than 0? Indicate the one tail test right. So our answer for t needs to be positive. So if pre minus post, we will get the negative value of t. So our answer will be wrong. After we got the difference, using calculator to find d bar indicate the mean, which is 2 and standard deviation I got 2.082. And just plug in into the formula and we got t equal to 2.542. So if you look at the graph, our t is inside the rejection area. Then the conclusion for this question is 2.542 falls inside the rejection area. Reject hash null and we conclude that the mean for the training was effective in improving customer relationship. Now look at the question B. The following is a partial ANOVA table. Complete the table and answer the following question. Use the 0.05 significance level. For question A, how many treatments are there? The question told us to find how many group we test, which is K value. So for my answer, this is how I do. We look at the table. Degree of freedom for treatments is 2. And the formula to find the TF for treatments is K minus 1. K is what we want to find. Then K minus 1 equal to 2. And the answer we got is 3. Next question. What is the total sample size? Total sample size indicates the N value. So this is how I answer. Look at the table. Our total degree of freedom is 11, right? Then we know to find the total degree of freedom is n minus 1. So n is what we want to find. Then n minus 1 equals to 11. And the answer we got is 12. 12 is the total sample size. For question C, what is the critical value of F? So to find the critical value, we need to find the degree of freedom for numerator and denominator. For numerator, indicate the degree of freedom for treatment, and denominator indicate the degree of freedom for error. For degree of freedom of error, from the table, just minus the total degree of freedom with degree of freedom treatment, which is 11 minus with 2 equal to 9. Now let's look at the table for F distribution and alpha 0.05. So our numerator is 2 and denominator is 9, and the critical value of F we get is 4.26. Okay, next question is write out the null and alternate hypothesis. So this is how we write down our H null and H1 for F distribution. In every question of H1 will be the means are all not equal, and our H null is referring to the group we test. We know that our K is 3, which is indicate the total group we test. The H null will be mu1 equal to mu2 and equal to mu3. What is your conclusion regarding the null hypothesis? So to find the conclusion, we have to complete the table first. Okay, firstly, we already got the total sum of square. Now we need to find the sum of square error from the mean square error. The degree of freedom error and the mean square error we already got, and we just change the place using the mean square formula. And we got 180. While for the sum of square treatment, we just minus the total sum of square with sum of square error, and we got 320. Then find the mean square for treatment by divide the sum of square with the degree of freedom of treatment, and we got 160. So for the F value, we got by divide the mean square of treatment with mean square of error and equal to 8. So the conclusion is 8 falls inside the rejection area. Reject H null. We conclude that the means are all not equal. Okay, now for the last question. Jacob Lee is a frequent traveler between Los Angeles and San Diego. For the past month, he wrote down the flight times in minutes on 3 different airlines. Use the 0.05 significance level and the 6-step hypothesis testing process to check if there is a difference in the mean flight times among the 3 airlines. So because there are 3 group we test, so we use F distribution. For step 1, there are 3 airlines, so our H null will be mu G equal to mu J equal to mu C. And our H1 will be the means are all not equal. From the question, our alpha is 0.05. Step 3, we use F distribution. Step 4, we need to find the critical value of F by calculating the degree of freedom numerator and denominator. So degree of freedom numerator is K minus 1. K is the total group we test, which is 3 minus 1, and we got 2 as the degree of freedom numerator. F denominator, total sample size, N minus K, and we got 32. Then we look at the F table, alpha 0.05. Our numerator is 2 and denominator is 32, but 32 is not in the table. Then we used 40. And our critical value is 3.23. Reject H null if calculated F more than 3.23. Step 5, we will using the table to find the value of F. Now firstly, find the current mean. Using our calculator, plug in each sample and find the mean. I got 52.17. Mean for each airlines, for airlines goes, I got 50.5, jet rate 52.07, and cloud trend 55.01. Okay, now find the sum of square total. By using the calculator, I got 796.97. Square error, I got 669.86. Find the sum of square treatment by minus sum of square total with sum of square error, and I got 127.11. Then divide sum of square treatment with its degree of freedom to get the mean square of treatment. Same formula for error, and we got 93.56 for treatment and 20.93 for error. Then for F value, using the formula mean square treatment divide with mean square error, and I got 3.036. Okay, then look at the graph in step 4. For the conclusion, 3.036 falls outside the rejection area. Do not reject H null. We conclude that the means are all equal. So that's all from us. Thank you.